Class, we're going to look at section 10.6 today. Now, we're going to be doing more factoring. If you remember, 10.5, we were factoring x squared plus bx plus c. Now we're going to look at what we do when we have a number in front of that ax squared, because we have to follow a different process. Now, our goal is to factor trinomials of the form ax squared plus bx plus c, but we are not going to follow the note-taking guide I typically do here, okay? We're going to use some different examples. So let's get started. So let's say we run into this. All right, 2x squared plus 23x plus 11. And the thing is we're like, all right, well, let's use that the method we did before. I need factors of 11 that add to 23. I don't think you're going to find any. You're not going to find any. And that rule doesn't work because, again, we have a number in front of x squared. So we have to follow a little different process. Now, I'm going to teach you two different ways. The first way is guess and check. We're going to use guess and check. And here's what you need to know for guess and check, okay? We're going to break this up into two binomials. Now, if you remember from the FOIL method, our first term is given by doing f, or multiplying the two first numbers together. Our last term is given by the L, where we multiply the last two numbers together. All right? And then that middle term, that's given by the outside and the inside. So there's our FOIL. Now, what we're going to do is we're going to use this blue and the green to create a good guess, and then we're going to FOIL it to check. Let's do that. So first, in order to get 2x squared, there's only one way I can multiply numbers to get to 2x squared, and that's doing 2x times x. Okay? Then for that last, for the green part, there's only one way to multiply to get to 11. That's 1 times 11. Now, I can put the 11 here and the 1 here. And you know what? Let's see if it works. We're going to test this by doing FOIL. First, 2x times x is 2x squared. Outside, 2x times 1 is 2x. Inside, 11 times x is 11x. And last, 11 times 1 is 11. That leaves me with 2x squared plus 13x plus 11. Shoot, it didn't quite work. So, let's move some things around. Let's try moving these green numbers. Okay? Let's try moving the green numbers. So this time we're going to do 1 here and 11 here. It's a guess. Now let's check. 2x times x is 2x squared. Plus outside, 2x times 11 is 22x. Plus the inside, 1 times x is 1x. Plus the last, 1 times 11 is 11. Leaving me with 2x squared plus 23x plus 11. Hey, that matches my original problem. I know this is the correct answer. So we use hints from our original trinomial to guess, and then we FOIL it out to check. Guess and check. Now, here's what I will say about guess and check. The better you get at this, the more you practice, guess and check, the better you'll become at guess and check, and it's typically the faster way, all right? I still use guess and check when I factor because, again, I've practiced it a lot, I've gotten pretty good, it's the faster way for me. But there are times when guess and check can be a little overwhelming, such as this. Let's say we want to factor 6x squared plus x minus 5. All right? So 6x squared plus x minus 5. And this honestly isn't even that bad of one. But let me show you. So again, we take that first number, and when we put that into our parentheses, that first number is created by doing the first, multiplying the first numbers together. And here's the thing, I can do 6x times x, or I could do 3x times 2x. So now we have more options that we need to guess and check. Because now we would put the factors of -5, you know, +1, -5, -1, +5, -5, +1, +5, -1. And if none of those work, then you got to do all the same for this. In fact, if you want to see all the options, here's all the options here. So we'd go through and we'd fill out all of these and we'd check each one to see if it works. Now, if you're getting good at guess and check, this isn't that bad, because you'll start to see patterns and you'll start to see how it works. It's hard to explain without telling you to just practice and see how it works. But you'll start to see some of these that just don't work, all right? And so you can narrow it down. But this is all the options you could do. And this would get even worse if we didn't have a prime number in our last number here, 5. Like if that was, God forbid, like a 24, it could be crazy. So here's what we can do instead. We can do something called the box method. Now, I have in your canvas at the very top of, at the very top of 10-6 box method directions. Okay, it looks something like this. It'll walk you right through this problem on how to do the box method, step by step. So that will be helpful. But I'm also going to show you what it looks like for this problem. So let's do it. So, we are going to use the box method on 6x squared plus x minus 5. So here's what we need to do. We need a box. We draw a box, and that box needs to have 4 places within it. In that box, the first term goes in the top left, 6x squared. And the last term goes in the bottom right, -5. Next, what we need to do is we multiply those two numbers we just put in. And we're just going to use the coefficient of 6x squared. So we're going to do 6 times -5, which gives me -30. And now I need factors of -30 that add to a +1, whatever our middle number may be. So I need factors of -30 that add to +1. So I go through my factors of -30. You know, 1 times -30, that would add to -29, that doesn't work. -1 times 30 adds to +29, that wouldn't work. 2 and 15 won't work, 3 and 10 won't work. We're gonna get all the way down to 6 times -5. Now 6 times -5 works because 6 times -5 gives me -30, and 6 plus -5 gives me +1. So those are the numbers I want to use. We're going to put those in the box, all right? So we're going to put 6 and -5 in the box, and it doesn't matter which one it goes to, all right? You can put your 6 here and the -5 here. You can put your -5 here and the 6 here. It doesn't matter, okay? We'll leave it like this, but what does matter is you need to attach an x to both, or whatever variable. If the variable's m, attach an m. If the variable's n, attach an n. You get it. Great. So we set up our box. The first term goes top left, last term bottom right. We then multiply the coefficient of the first term and the last term. So 6 times -5 to give us -30. And we need factors of -30 that add to +1. Once we find those numbers, in this case it was 6 and -5, we put them into our box and attach a variable to both. Great. We have the box all set up. Here's what we do now. Now we need to find the greatest common factor of every row. So let's start with that. The greatest common factor of 6x squared and 6x is 6x. The greatest common factor of -5x and -5 would be 5 technically. However, if they're both negative like this, we factor out a -5. And now we need the greatest common factor of both columns. The greatest common factor of 6x squared and negative 5x would be a positive x. The greatest common factor of 6x and negative 5 is 1. Now, you ready for this? Here's the great part. These should be our factors. X and positive 1, or how about x plus 1? 6x and negative 5, or how about 6x minus 5? Now, of course we should check our answer, all right? The box method, you always need to check your answer. So let's go ahead and FOIL this. X times 6x is 6x squared. Outside, x times negative 5 is negative 5x. Inside, 1 plus 6x is 6x. And last, 1 times negative 5 is negative 5, leaving me with 6x squared plus x minus 5, which as you can see matches my original expression. Therefore, I have the right answer. So, if we have a number in front of our x squared, okay, and we can't factor out that number, which I'm about to show you an example of what that looks like, we need to either use guess and check or the box method. Now, sometimes we get lucky. Sometimes we get lucky. Let me find a blank slide here, perfect. Sometimes we get lucky. Let's say we have this. 2x squared minus 2x minus 12. All right, 2x squared minus 2x minus 12. So as you can see, I have a number in front of my x squared, so I can't just use the method that we like to do, the factors of the last number that add to the middle number. Can't use it because of that number in front of our x squared. So we're thinking to ourselves, well, we have to use guess and check or box method, but hold on. Before you do that, I want you to always look for this situation. If you look, 2x squared, negative 2x, and negative 12 are all divisible by the same number, in this case, 2. So what I can do is factor out a 2, leaving me with x squared minus x minus 6, because 2 times x squared is 2x squared, 2 times negative x is negative 2x, and 2 times negative 6 is negative 12. And now, see what's left over in here? Now we have a quadratic trinomial that has a 1 in front of the x squared. So now we can use the strategy we used before, where we just find factors of negative 6 that add to negative 1. In this case, negative 3 and positive 2. Because negative 3 times 2 is negative 6. Negative 3 plus 2 is negative 1. All right? Then we just need to remember to bring the 2 down. This is our fully factored form. So, to wrap this all up, if you have a number in front of your x squared, first, look to see if you can factor out a common factor, okay? In this case, I factored out a common factor, and what I was left with was easily factorable using our old method. If you cannot factor out a common factor, such as this problem, 6, 1, and negative 5, there's no number that divides all those. Well, there's 1, but that doesn't help us. Then we either need to use guess and check or the box method. All right, do your homework.